Hello, my name is Taisar Slabekov, and I'm a chemistry major at Georgia Tech. Today I will be discussing the changing poles, or how the ice cores and the atmosphere in the Arctic and the Antarctic are being drastically affected by climate change and human activity. The key idea of this presentation is how chemistry and analytical techniques are being used to measure and track the aforementioned changes in order to quantify the urgency of the situation, predict its effects, and provide advice for the future. Here's a brief summary of my presentation, which begins with an evaluation of ice core analytical techniques, their implications, and then the equivalent for atmospheric composition. Both of these locations are being wildly affected by human activity in their respective ways, leading to drastic changes in the polar ecosystem to the record-breaking point. Although the ice cores are intimately tied to the atmosphere, they provide a greater wealth of information for the entirety of Earth's history as a basis for comparison, whereas atmospheric compositional analysis shows the most recent effect of human actions. So what exactly are ice cores? Ice cores are simply samples of ice from deep beneath the surface layer that are drilled with special instruments to not damage the fragile ice. When ice forms, it traps air bubbles as well as other small molecules from the current era, and these bubbles and sediments can be extracted and studied. Ice cores can contain information from as long as 800,000 years ago, allowing scientists to measure ancient temperatures and concentrations of greenhouse gases, as well as establish levels from pre- and post-industrial revolution humanity to quantify its effects. The dark band that you see in the right image is a deposit of volcanic soot and ash from over 200,000 years ago, showing just how far back the information that these ice cores stored dates. How do scientists measure these concentrations? Scientists put small samples of ice into inductively coupled plasma mass spectrometers in order to determine the concentrations of elemental nitrogen and sulfur in these ice cores. Nitrogen and sulfur both are chemicals that are naturally found and should be found in ice cores as byproducts of inorganic matter, but their concentrations have been steadily increasing post-industrial revolution as byproducts of human activity, as evidenced by the graph. These atoms can be re-emitted into the atmosphere with increasing temperature in the passage of time, leading to the exacerbation of the greenhouse effect and contributing even more to global warming. These ions also create a pH imbalance in the pristine ecosystem, changing the environment for the fragile polar organisms, disrupting the flora, fauna, and even the water. These measurements can be compiled to view trends across eras, as shown by this graph. It graphs the concentrations of carbon dioxide and methane, some of the biggest contributors to the greenhouse effect against time, and the increase in the current era is indubitably unprecedented. These values were similarly obtained from the ICP-MS instrument and can be attributed to human activity, such as agriculture and fossil fuel production. Although ice core composition analysis by itself provides no direct analog for the future composition, since there are no periods with concentrations of CO2 even slightly similar to that of the next century, when combined with atmospheric composition analysis, that I will discuss soon, computer models utilizing this data show the urgency of the situation, that human actions are causing irreversible change to both the cores and atmosphere, ruining the pristinity of our Earth. Our ice cores have never in the entire history of Earth had this composition. It is completely novel, as evidenced by the aforementioned research. With such a plethora of detrimental molecules in the ice cores, from carbon dioxide, methane, to sodium and sulfate ions, such harmful activities such as agriculture and fossil fuel production, without taking into account the effects on the environment, must be stopped and reevaluated. Not only are the ice cores being unrecognizably altered, but also the atmosphere above the poles, which used to be the most pristine location on Earth. Since the atmosphere is a gas rather than the solid ice cores, a different analytical technique must be used, spectroscopy. Samples of the gaseous atmosphere are extracted and illuminated by different wavelengths of light, usually infrared or ultraviolet, in order to measure the energy and intensity of the light re-emitted by the molecules of the atmosphere when they are excited by such light. Different bonds within molecules and the atoms within vibrate with different and unique frequencies when hit with such light, so it's possible to identify them this way. One of the main molecules that should not be detected in an unpolluted atmosphere is bromine, which is one of the main contributors to the depletion of the ozone layer. As shown in this reaction, high levels of bromine in the atmosphere can react with ozone, O3, decreasing its levels. The ozone layer is one of our main layers of protection against harmful and powerful UV rays from the sun, and decreasing the effects of the greenhouse effect, and without it, the already bad situation worsens. Similar to its effect in the ice cores, sulfate ions also contribute to the drastic changes in the atmosphere. Graphs A and B show that the radiative forcing contribution of sulfate, or the difference in the amount of energy that enters versus leaves the surface, leads to a net increase in the temperature of the atmosphere. Same goes for black carbon, as seen in graph C and D, which is fine carbon emitted from gas and diesel engines and coal-powered plants, which is a major contributor to pollution. These graphs show that it leads to a substantial increase in the surface temperature of the poles, and thus it is incredibly detrimental. When both of these chemicals combined, as shown in graphs E and F, the effect is exacerbated, which means that the changing atmospheric composition above the poles is also leading to drastic changes on the surface, i.e. heating it up, leading to climate change. Therefore, the atmosphere is intimately tied to the ice cores and the surface. But why have scientists been focusing so much on the polar atmosphere all this time? Well, it used to be the most pristine environment for billions of years, and thus any changes in it can be attributed to almost virtually to human action. Thus, it is easy to quantify these effects here, and the cascade of the consequences permeates throughout the ecosystems all across the Earth. These changes in the environment of increased chemical concentrations, as aforementioned, make algal and phytoplankton blooms more common, ruining the aquatic environment for already endangered species. These environments sequester almost half of all of the CO2 emissions produced by humans, and with the decreasing effectiveness of this filtering, the effects will be more felt all around the world, such as decreasing air quality and changes in ecosystems all the way to the equator and back. The polar environments act as a filter for humanity, yet they are being hit the hardest by human actions. But does this mean that we are all doomed, that there is nothing we can do? Quite the contrary. All of the aforementioned evidence for changing chemical composition can be put into computer models to predict possible outcomes, which of course are absolutely dire, but the earlier humanity starts cutting down on carbon emissions, deforestation, fossil fuel production, and other methods of introducing noxious chemicals into the surface and the atmosphere, the faster the poles can revert to the pristine conditions and filter out all of humanity's mistakes. Just look at this animation showing the absolutely unrecognizable size of the polar cap in just the last 20 years, all due to human action. Although completely stopping all CO2 emissions will not save us from some sort of disaster, it is of utmost importance that humanity undertakes immediate action, actually listening to the evidence found in the polar cores and atmosphere, that the Earth is not the same Earth that it was even 20 years ago. Thus, chemical analysis shows that the only solution to save humanity from damnation is to fix its actions. Thank you so much for listening to me today, and here are my sources.